Here we go. All right. Oh, there's Arwen. Okay. So we have our lesson 5.8, rational zero theorem. All right, rational zero theorem. So what we're going to do is we're going to use this theorem to help us find all rational zeros of a polynomial. Okay, so let's dive into this. And man, oof, that looks complicated, doesn't it? Okay, so let's break this down. Let's dissect this. We have, let this function f of x be this gnarly looking thing, okay, where you have x to some nth power and it decreases, decreases, decreases all the way down to a sub 0, which doesn't have an x, all right? And that's our polynomial function. And the rational zero theorem tells us that if p over q, all right, and just two random letters, p and q, if that is a rational number in simplest form, and we know it's a zero of this function, the numerator, p, will be a factor of a sub 0. So this a sub 0. So that numerator will be a factor of a sub 0, that constant. And then q will be a factor of a sub n, that leading coefficient. Okay? So a sub 0 is that constant, and a sub n is this leading coefficient. Okay, so I'm sure that probably did not make a lot of sense. So let me see if I can put this in like normal person terms, okay? So normal person's terms. And I'm going to use example 1 to kind of demonstrate it as well. So in our own words, what we're going to do is to find all possible rational zeros, step 1 is to find all factors of the constant. And what I mean by the constant of the polynomial is the number without a variable. The number without the variable. So in number 1, right, look for the constant. And hopefully you're looking at negative 49. That is the constant, okay? I would say this for this part, don't worry about positives or negatives, right? That's a negative 49, but I'm just really focusing on finding the factors of 49, okay? And I'm going to call the list of these factors, I'm going to call that P. And I'll label this P up here as well. So 49, factors of 49, 1 goes into 49. 2 doesn't, 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, 7 goes into 49. And 49 goes into 49. Okay, so those are all the factors of 49. Okay, so that's step 1. Step 2, find all factors of the leading coefficient. All right, so find all factors of the leading coefficient. I'm going to label this list Q. All right, so in this case, Q is the leading coefficient here of 1. So the factors of 1 are just 1. And by the way, the leading coefficient isn't always just that first number that pops up. You have to look at the exponents, right? So make sure those exponents are going from the highest to lowest, okay? Highest to lowest. And the number that goes with the term with the highest exponent is the leading coefficient. For the most part, they're in order though, so you don't really have to worry so much. But just in case there's like a little trickiness there, make sure those exponents are in order. Okay, so that's step 2. Let me take a quick pause. Any questions about finding the factors of the constant and the leading coefficient? While I take a sip of my milk tea. Everyone's good still? Okay. All right. Step 3, we're going to take the first list and divide it with the second list. All right. So step 3, I'm going to divide list 1 and list 2. And don't forget pluses and minuses. All right. So with these factors, it can be plus or minus. So let me do that down here. So what I mean by that is I'm going to put the P list and divide it with the Q list 1 by 1. Okay. So if I look at my P list, I have 1. And then if I look at my Q list, I have 1. So 1 over 1, I get 1. And then 7, I'm going to go through my list, right? Go through my list. 7 over 1 gets me 7. And 49 over 1 gets me 49. And I need pluses and minuses in front of each of these numbers. All right, so 1 over 1, 7 over 1, 49 over 1. And that is my list of P over Q. Okay. Now, this basically, step 4, well, it's not really a step. It's basically telling us what this final list is. So this final list are or is all the possible, all right, possible rational zeros of this function. Okay. So this list right here, P over Q, is the list of all possible rational zeros of the function. All right, any questions? Okay, so let's go to number 2. All right, this one's a little bit different because the leading coefficient I can see already is 2. Okay, so step 1, list the factors of that -5 or +5, it doesn't matter because we're gonna do pluses and minus later on anyway, which is why it doesn't matter. So factors of 5 are just 1 and 5. Factors of the leading coefficient of 2 is 1 and 2. All right, so let's do P over Q. So I'm going to start with my Q of 1, and I'm going to go through my list of P's. So I got 1 over 1, which is just 1, so plus or minus 1. And then I'm going to do 5 over 1, which is plus or minus 5. All right, so I'm done with that first. I'm going to check that off. All right, first Q, done. Second Q, I'm going to do the same thing. 1 over 2 gets me positive and negative 1/2. 5 over 2, plus or minus 5 over 2. Please do not put that into a mixed fraction. OMG, do not do that. Okay, just keep it like 5 over 2. It's less work, less careless mistakes, and it's neater and nicer to look at. All right, and that's it. Check, done with the second one. All right, questions on that one? Okay, let me go ahead. I'll show you one more and then I'll start calling on people. Number 3. All right, number 3, this one, ooh, I got lots because I'm looking at my leading coefficient, I'm looking at my constant, and I got lots of factors here. So P, factors of 21, I got 1, 3, 7, and 21. Okay. Q, factors of 6. I have 1, 2, 3, and 6. All right, so I got lots to work with here. Let me let my iPad catch up a little bit. So we're going to do P over Q. P over Q. There we go. All right. So P over Q, let's go through our list. I'm going to start with Q is 1. And I'm going through my list of P's. So I'm going to divide all my numbers in P, divide it by that 1. So then I get plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. Okay, done with Q being 1. Let's go through the entire list of P now with a denominator of 2. So plus or minus 1/2, plus or minus 3 over 2, plus or minus 7 over 2, plus or minus 21 over 2. Done with Q equals to 2. Continuing, Q is 3. Plus or minus 1 over 3. Plus or minus 3 over 3. Oh, wait, actually. Ooh. Plus or minus 3 over 3, what does that reduce down to? 3 over 3 is equal to, anyone?
1.
Yeah, equals to 1. Do we already have that in our list? Yeah, we do. So don't worry about writing it again. All right. So don't put 3 over 3 because that reduces to 1. And we already have plus or minus 1 right in the front there. So skipping that, already have it. Next, I got 7 over 3. So plus or minus 7 over 3. Plus or minus 21 over 3. Well, 21 over 3 is equal to 7. I already have plus or minus 7. So I don't want to write it. I don't want to write it again. It makes my list longer than it already is, right? So don't worry about that. Skip it. And we are done with the 3. Okay, moving on. Q is 6. Plus or minus 1 over 6. Plus or minus 3 over 6. Well, 3 over 6 is 1/2. Already got it. Don't need it. Plus or minus 7 over 6. Plus or minus 21 over 6. 21 over 6 is 7 over 2. Yeah, 7 over 2. Already have it. Don't need to rewrite it again. All right. So that means after 7 over 6, I'm done with my list. And that should be my final answer. Sorry, my iPad is super slow right now. Cool. So there it is. Now you can see my answer. Okay. Huge list. Any questions? Yeah, everyone's good? Oh, I hope so. Okay, cool. If that is the case, if not, I got one more problem for you to see if you can figure it out. And after this one, if you are still not sure, definitely put questions up in the chat, okay? All right, let me start calling on people. Here we go. Number 4, what is your first step? Tell me what to do. Gio, start us off.
So first you find the factors of the constant.
Good.
So that's the P. So you have 1 and 11.
Perfect.
And then you find the factors of the leading coefficient, and
Good.
that's Q. So you have 1 and 2.
Perfect.
And then you divide all the P's by 1Q, and you go down the list. So you have 1 by 1, so that's plus or minus 1. So P over Q plus or minus 1, and then plus or minus 11, and then plus or minus 1/2 because you do it by 2 now, and then plus or minus 11 over 2.
Perfect. Nice. Great job, Gio. Nailed it. Awesome. 100%. 100%. All right, guys. That is it for this type of questions. concerns, put in the chat if you need any help with those. Okay, I don't see anything. All right, well, if you think of some stuff later on, feel free to put it in the chat anytime you want, guys. Okay, but if not, let me move on to finding all the rational zeros of the function. All right, we're kind of getting closer to our main event here, which is to find all the zeros. But now we're just going to stick with just finding the rational zeros, okay? These lists, numbers 1 through 4, these were the possible rational zeros, not the actual ones, not the actual ones. Now for number 5, they want the actual ones and not all of the lists, right? If you can see, number 3's list is huge. Not all of them are actual ones. So let's find out which ones are the actual ones. So this is how you do it. First, we're going to list out the possible ones, right? Start with that list. So do the same thing we did before. List out our P factors. So 1, 2, 4, 7, 14, 28. Q factors, leading coefficient is 1. All right, so P over Q, we have plus or minus 1, 2, 4, 7, 14, and 28. All right, and this is the list we're gonna work off of, okay? And what you guys actually have to do is just guess and check. All right, I know that's not a great strategy, but you really just guess and check and go through the list until you find some zeros. All right, and really you only need to find one, because once you find one, you can use the depressed polynomial, excuse me. You can find factors after factoring the depressed polynomial. So really we just need one. We just need one. Okay, so let's see, Queenie. Pick a number in the list, any number that we can just test out.
4.
4? Okay. 4. All right, so I'm going to test out 4. Okay, so we're testing out this guy right here. And I'm going to use my polynomial up here. So I got 1, 4, -25, -28. Double check if there's any missing terms, any zeros that I need to put in. Doesn't look like it. Okay. So drop it down, multiply, add, multiply, and add, multiply. Whoa, Queenie. Queenie, was that a good guess or did you know?
No, I just guessed it.
Really? Oh my gosh, that's amazing. So Queenie got it on her first try. Good guess, Queenie. The reason why I'm so happy is because 0 is the remainder. Most of the times you're not going to get 0 as a remainder. And if you don't, that means you have to keep testing out different ones until you get 0. But this is great because if this is a 0, if the remainder is 0, that means that this 4 is a 0 of the function, okay? So I think that's an easy way to remember it, right? If the remainder is 0, if this is 0, that means this is a 0, okay? All right, good guessing, Queenie, nice. Now from there, right, I need to find all the rational zeros. I got 1. I don't want to keep testing out the rest of them because I have a better strategy. I can use my depressed polynomial, right? X squared plus 8x plus 7. And I can factor that. And I can factor that to be x plus 7 times x plus 1. Which means this is going to have a 0 at x is equal to -7. And this factor has a 0 at x is -1. And those are all the zeros. X is 4, right? This one right here. X is -7. And X is -1. Oops. And that is your final answer.
Miss Leong, I have a question.
Yeah, go for it.
Is there any easier way than just guessing for the first part, or if you have to guess and just hope for the best?
I know.
Is there like a trick, like you can see from the number that it'll equal have a zero remainder, or you just like have to guess?
It's oh man, that's such a good question. I totally understand why you're asking that because this list just seems tremendous, and you're like, I don't want to spend like half my quiz time going through just guessing and checking. So I'll let you know this. For the quiz, which I'm writing this time, okay, I will give you a manageable list. It will not be this long. So even if you had to, guess and check all of them, it shouldn't take you that much time. It will be manageable. It will be maybe the length of like number 2 or number 4, right? It'll be like, or number 1. It'll be a manageable list. Are there tricks to kind of narrowing it down? Yes, but there's a lot of theorems that we just haven't gone through to get to all those tips and tricks. So yes, but not right now, if that makes sense.
Yeah.
Yeah. Okay. Yeah. So yeah, I wish I can give you a quick and easy way to like spot the right one. Unfortunately, there isn't a way to just like spot the right one. Yeah. Okay. Let's go to number 6, and then I'll show you guys a few more just to kind of get you all used to this. Oh, actually, number 6 is nice, guys. Number 6 is real nice. How I can tell is I can factor this by using grouping. So if you can factor it using grouping, do that. That's way faster. You don't need to list any, possible rational anything, right? I can pull out x squared here. I can pull out the 4, and I can see I get twins. So that is great news because you can just factor it and get the zeros from there. So this guy, this factor will have a 0 of x is equal to -6. This guy, this factor, if I set that equal to 0, subtract the 4, square root, I get plus or minus 2i. Now the directions though say list all the possible rational roots, rational. So I actually don't need the plus or minus 2i. This x is equal to -6 is the only rational root. So that is my final answer. Okay, so check first to see if you can factor. Number 5, I can tell I can't factor by grouping. I wouldn't get twins. So that's why I didn't do it. But for number 6, I noticed that. So that could save you a lot of time. All right, let's move on to number 7 and 8. This is kind of like the main event. This is what we've been leading up to. And now instead of finding just the rational ones, we are finding all of the zeros. Rational, irrational, imaginary, all of them. Okay, so let's try this one. So first off, can't factor it. So I'm going to list out all my zeros. Okay, so I have my P. And actually, I can see that Q is already 1. So I'm going to get straight to P over Q because Q is already 1. It's just going to be the factors of the 60, right? So jumping straight to that, I get plus or minus 1, 2, 3, 4, 5, oh gosh, 6. All right. Not 7, not 8, not 9. Okay, so then 10 comes from the 6. All right. 60 divided by 5 gets me 12. 60 divided by 4 gets me 15. 60 divided by 3 gets me 20. 60 divided by 2 gets me 30. 60 divided by 1 gets me 60. Okay, I wish I had a trick, Geo. I really do. Okay, now we kind of got to guess and check. So let me see. Faith, pick a number from that list. Let's just try it.
6.
All right, let's try 6. Let's see if we get lucky. All right, so 6. Let's try it. And I got 1, 2, negative 11, 8, negative 60. And this is a really good way to get good at synthetic division. This is good practice. All right, so 37 times 6, I get 42 is 6 times 7, 12, so 162. Oh no, that's not right. Got to do this on the side. 2, 4, 18, 222. That's 230. Okay, I know this is not going to work. Okay, this is definitely not going to give me a remainder of 0. So I'm just going to stop there. Oh, here's actually one of the tricks, Geo, that I was thinking about, but it was hard to explain without an example. Because the number 6 gave me such a big positive number, I'm not going to try like positive 8, positive 12, positive 15, because the numbers are just going to get bigger and bigger and bigger. And it's not going to get to 12. So that's kind of like a way to eliminate some of your possibilities. Okay.
So you should like start in the middle and then see which type if you need to go up or down.
Kind of, yeah. I think that's a good way to put it. Yeah. So let's try, I don't know, let's go halfway. Let's go 3. Okay. And you can kind of see what happens to the numbers on the bottom. You want to try to get that to 0. That's the goal, right? You want to get that remainder of 0. So let's try 3. And let's see if we need to go like above or below after that. Okay, so drop down 1, 3, add, get me 5, 4. Okay, doing good so far. The numbers are pretty low. Blanking out. 12 plus 8, 20. And ooh. Hey, even better. All right. Love it when I see that 0. Okay, so this remainder is 0. So this is a 0. So yay. We got 1. Okay. And what you could do is you could keep testing out all the other ones, but if this is factorable, let's see if this is factorable. It looks like it might be. Okay, so this is going to be x cubed. Reason why it's cubed is because the original one is 4. You always go 1 less than that. Okay. Pull out the x squared. Pull out the 4. Ooh, and we get twins, guys. This is good. All right, so then we get x plus 5. And we're left with x squared plus 4. Yay, we are factored. So now we can get our zeros. So this factor gives me a 0 of x is equal to negative 5. This factor, set that equal to 0, gets me x is equal to square root, plus or minus 2i. Okay, this time they want all the zeros. So I'm going to take all of them. I get x is equal to 3. I have negative 5, positive 2i, and negative 2i. All right. Now, the reason why I kind of listed it out like that, I didn't keep the plus or minus 2i, is because watch. This is kind of cool. Look how many zeros I found. I got 1, 2, 3, 4 zeros. Look at my exponent. Oh, that is not a coincidence. The number of zeros you find should always match the degree of your function. All right, the number of zeros you find at the end should always match the degree of your function. All right, any questions on that? Okay, we are quickly running out of time, so I'm going to do number 8 really, really fast. And you guys can go ahead and do number 8 alongside me. All right, so if you get stuck, you can look around, you can look over and see kind of how to do it. Or if you just want to double check and make sure you're on the right page, you can go ahead and look over as well. Okay, so let me quickly do number 8 with our remaining couple minutes here. All right, and you practice while I'm doing this as well. All right, I'm going to cheat a little bit and I'm going to look at which one works because of time. Oh, careful, please do not leave until I excuse you. Unless you have to, then you let me know. All right. Whew. Sorry, guys. I know we're over time right now, but this is my final answer. X is equal to 1, 0, another 0, another 0, and another 0. I got 4 zeros with my degree 4 polynomial, so I know that is it. Okay. All right, if you guys have any questions, stick around. If not, I will see you tomorrow.